Hey there, we're going to show you a moles to grams problem now, and I wanted to give you a couple of pointers before we start. The first pointer I want to give you is one that you're going to hear a lot, and that is start with a balanced chemical equation. Now if you're in regular level chemistry, you're probably going to get the equation pre-balanced, and that's nice, and you'll get the right numbers in front of the substances that are there, and that's all great. But if you're in honors or if you're in a more advanced AP level class, watch out, because sometimes they give you the equation and it looks like everything's fine, but it hasn't been balanced. So watch out for those additional steps and make sure you're dealing with a balanced chemical equation. Alright, second thing is that once you have the balanced chemical equation, those coefficients represent the molar ratios. So now you know if substances are related like 2 to 1, 1 to 2, because those coefficients reflect the molar ratios. You also need a periodic table, because if you're going to look up masses, you really need a periodic table handy, and nobody expects you to know the masses for, hydrogen or carbon off the top of your head. I might, because I'm an expert at this stuff, but you don't have to. And even still, for some of those elements, even somebody like me needs to look up stuff in the periodic table once in a while. All right, now, these kinds of problems you're going to need to use not one, but two conversion factors. So get ready, I'm going to show you how it's done, and I'll see you at the end of the video. Okay, we have a grams to moles problem for you, and boy, oh boy, does this look like a big problem. I mean, God, look at all that stuff. How am I going to figure this out? Well, it's going to be a little bit easier because the equation has been given to me balanced, so I don't need to worry about doing anything with the coefficients. Let's just read the problem slowly and figure out what it's asking. So the problem says, how many moles of water, right, that's important because that's what I'm looking for. How many moles of water are produced when 28 grams of phosphoric acid reacts completely with sodium hydroxide? All right, well, this is going to be my starting substance, this 28 grams of phosphoric acid. So that is my start, that's substance A. And what I'm looking for is my moles of water, so that's substance B. Now, in the equation, substance A is right here, and substance B is water, so that's of course this one over here. And now I've identified what we are given and what we need to figure out. So let's make a roadmap for how to go from point A to point B, literally. Okay, so we're going to start with grams of substance A. We are then going into moles of substance A, and then from here we're going to go into moles of substance B. And once we do that, we'll be done with the problem, and then we can do the victory dance. Woohoo! All right, so I'm going to cap that pen, and here we go. We got 28 grams to start with, so 28 grams of H3PO4. And remember, we're always starting over 1. Okay, now to go from grams to moles, I need to know the molar mass of phosphoric acid. And where do I get my molar mass from? Dun, da, 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 periodic table. All right, you guessed it. So if you didn't have a periodic table handy, hit pause, go grab one real quick, I'll wait for you, and then hit the play button and we'll pick it up from where we left off. Of course, you're also going to need a calculator to do some calculations, because you're going to see this problem is going to involve quite a few. All right, now in this space down here, what I'm going to do, I actually lift up my paper a little bit, I'm going to work out the molar mass of phosphoric acid. I'm going to have to take 3 times the mass of hydrogen, 1 times the mass of phosphorus, and 4 times the mass of oxygen. You can see that's H3PO4. All right, so that's why I had 3 hydrogens, 1 phosphorus, and 4 oxygens. All right, so let's figure that out. Here in the periodic table, hydrogen has a mass of 1.01. So I've got 3 times 1.01, which is 3.03. For phosphorus, we have to go to the other side of the periodic table, because phosphorus and oxygen are neighbors, but they're neighbors on this side of the periodic table. So my periodic table says the mass of phosphorus is 30.97. So since that's 1, it's just 30.97. And then I have 4 times the mass of oxygen. So oxygen has a mass of 16. So you can use your calculator if you want to. 4 times 16 is 64. Now, once I've got all these masses, I'm going to add them up, and that'll give me the molar mass of phosphoric acid. So 3.03 plus 30.97 plus 64. And there it is, 98 grams for phosphoric acid. Okay, now that's the amount in just 1 mole. So that's per 1 mole of phosphoric acid. All right, so I've done all that calculation just to figure out how much 1 mole weighs. Okay, or actually not weighs, but the mass of 1 mole of phosphoric acid. All right, didn't want to incite the ires of the physics people by using the wrong word. Anyway, I meant mass. You know I meant mass. Okay, here we go. 98 grams of H3PO4 and 1 mole of H3PO4. All right, so all of that work that I did down here was to figure out the molar mass of phosphoric acid. And now that I did that, I continue with the rest of the problem. Whew. All right, goodbye mass. Okay, last step. We're going from moles of A to moles of B. Looking at the equation, I don't see a number here, but that's all right, because chemists usually don't write ones. They don't write ones when there's only one of that particular substance. So the ratio between A to B is 1 to 3. Hey, that rhymes. A to B, 1 to 3. Now, it doesn't always rhyme, but I kind of like that just for this particular problem. Corny, I know. I know. It's corny, but I got to tell you, people, sometimes that's the way I roll. All right. So it's 3 moles of water. That's substance B. Almost forgot, but since I'm labeling everything so well, I can't possibly forget. I mean, once you write moles up top here, you want to make them cancel, so you write the moles of phosphoric acid down here. And by the way, even if I did forget, look, I've labeled everything. So if I want to know what I'm doing, I just look at my roadmap. Hey, I'm going from moles of A to B. What was A again? Oh, there it is. And hey, what was B? Oh yeah, B was the water. All right. So you can remind yourself if you label everything really nicely. All right, well, not to talk too much. I'm kind of rambling a little bit on this problem, but I like to be thorough, and I like to throw a little comedy in. So here we go. We're going to multiply the tops and divide the bottom. So 28 times 1 times 3, and that's multiplying the tops. Now I divide by 1, divide by 98, and divide by 1. And our final answer is here. Okay, 0.857 moles of water. Now, don't get freaked out if you don't get an answer that's like even or something, like 4 or 2 or 1 or whatever. It's perfectly normal to get an ugly decimal answer. And in some chemistry problems, you may even have answers with scientific notation, which can look even uglier. But whatever the answer is, the most important thing is that you follow the process. What do you follow? The process, exactly. Now, at this stage, we're done. And if you understood everything I did, great. But just to reinforce this, I would hit the rewind button on the video, start from the beginning where I actually show you the original problem with nothing solved, and see if you can follow the process from beginning to end, including writing out the roadmap as you go from grams of A to moles of A to moles of B. And that's all I have for you right now. I'll see you next time. Hey, wasn't that awesome? All right, well, maybe it wasn't awesome, but at least you now understand a little bit more chemistry than you did before. All right, so a couple of key points to keep in mind for all of these stoichiometry problems. First, you always have to start with a balanced chemical equation. That's a must. You can't go anywhere without it, because otherwise your conversion factors get all screwed up, and then you get wrong answers, and then wrong answers don't make you happy. All right. Second thing that you have to keep in mind is that along the way you might feel confident, and that's good, but I want you to feel more confident. But I want you to keep practicing as well. I don't want you to stop just because you were able to solve one problem correctly. You need to keep going and practice a few problems until it's like tying your shoelaces. You know this backwards and forwards. All right, and then the final thing I want you to keep in mind is that if you're running into trouble, always make sure that you're labeling your units along the way. So that way, if there is a problem and you don't get the right answer, at least you can backtrack and kind of problem solve and figure out what step might have gone wrong. All right, that's it for now. Remember, watch another video, get good at chemistry, and I'll see you soon.